Hi, my name is Andrew Gillis, and I'm a software engineer currently working with the Bedrock team on the Indexer project. And I'd like to take this time to present to you our plans for taking the Indexer to the next level of scalability. So here's a rough idea of the kind of scalability we're talking about. Our goal being 10 to the 15 indexes. So to give you an idea about what that means, if you look at the small red square in the corner, that's represents 1 billion indexes, which is about what we are currently getting in 12 to 24 hours. So 1,000 times that, 10 to the 12th, would probably, given the rate of acceleration of indexing data coming in, would probably be something that we'd start seeing in maybe in less than a year. And then looking at the large gray block, our eventual goal, something that it's a little bit harder to estimate the time on, but I would say rough guess maybe 5 years. Here's where we are now. We are at less than 10 to the 12th, which is basically the whole blue block, or one small bit in that big gray block. So we want to be able to eventually get to be able to handle all of the data represented by that lower block, but it's going to take some time. It's not going to get done all at once. It's going to take a number of steps to get there, and we're going to have to proceed in a way that allows us to course correct as we go forward, accommodate new features, and understand how the growth velocity changes when new patterns of usage, technologies, things like that are experienced by the indexer. But we're taking steps to eventually to get there, and the next steps we're going to take should hopefully get us a couple orders of magnitude closer to our end goal. So what needs to be done first? Well, to figure out what we need to do first, we have to look at what the indexer struggles to do the most. Currently, the vast majority of the indexer's work comes from ingesting all the index data published. It's a huge amount of data that's being published every day, and that's increasing. We see sustained rates of 20,000 to 60,000 new indexes per second, and that's normal. Over 7 billion new indexes per week, which is increasing every week. We already have over 200 storage providers indexing content, and we're adding more all the time. IPFS is now indexing through reframes. So we are increasing the velocity of the data we're ingesting. So let's understand the ways that overloads the indexer. A couple ways. One is the sheer volume of data. The indexer just can't keep up with being able to process it, be able to pull it all over the network, and be able to deal with processing and storing it. It's the absolute volume of data is too much for it. And when the indexer gets backed up and it starts getting behind in its backlog of work that it has to process. And that means we need a scaling strategy so that we can divide all of this incoming data among multiple indexers, so that no one indexer is forced to handle all of that data and become overloaded. Another way that indexers can become overloaded is due to exceeding storage limits. So every node at some point is going to have a limit to how much data it's going to store. That can be imposed by hardware, infrastructure, or simply because as its data store grows so huge, it becomes too slow to update and access. So we have to have a strategy that accounts for a way of handling when indexers reach a maximum capacity. We have to be able to do something to hand off responsibility or redistribute data or something, so that the storage load is not too much for any one indexer to handle. So this gives us some ideas for basic requirements. We need to be able to handle adding indexers anytime as the capacity as we need to increase capacity in our indexing deployment. We'll need to be able to add indexers. Any indexer node must be able to gracefully hand over work when it's full, when it reaches capacity. Even if it's from a single data source, we need to be able to have some way of handling when an indexer can't absorb any more data. We also need redundancy, because if we're indexing huge amounts of data, it can be very expensive to lose that data if an indexer goes down. So we do want to have the ability to have redundancy within our deployment. And since we don't know exactly which indexer is going to ever have a particular piece of data, we'll need a way of sending queries to all the indexers so that we can merge the results, because the result that we want may come from any of them or all of them. So the decision we've made to split up the work of ingestion is to divide the publishers over the indexers in a pool of indexers. The publisher is the entity that publishes indexing data, indexers. It may or may not be the same as the actual content provider. So this strategy is very simple, and it allows us to assign indexers a publisher, and then after they're assigned a publisher, the indexer can interact independently and directly with the publisher, and it doesn't require any use of any sort of upstream service to parse and redirect data to indexers. Indexer can just interact directly with the publisher. And in order to decide how we assign publishers to indexers, we're going to use a coordination service. A coordination service is a simple service that is going to listen for announced messages over pub sub or coming directly over HTTP. The announced messages are just when a publisher says it has new data to index. And it's going to look at the publisher and that announced message and see if it's already been assigned. If it has not been assigned to an indexer, the coordination service will decide on an indexer to assign it to. After assignment, the indexer will be told to sync to that publisher. And from then on out, the indexer will act independently with that publisher. And the coordination service doesn't need to do anything more for that publisher. The coordination service was chosen because it's a very simple way of making the decision for the indexers, and it doesn't require any sort of consensus mechanism to be shared amongst the indexers to find some way to agree on who gets which publishers. And it's also really not a single point of failure, certainly not in the short term, because the coordination service can go offline and the indexers will all continue to operate just fine without it. And then when the coordination service comes back online, it can resume assigning publishers to indexers, and everything will catch up as they go and index the content. Nothing will be missed. So what's an indexer pool consist of? Well, an indexer pool, it's also very simple. It's just a group of indexers that a coordination service is configured to control. And all that means is the indexers are on the same network and their administrative interface is available to the configuration service. And the indexers can be put into the pool by updating the configuration, the coordination services configuration, and can be removed from the pool the same way. When an indexer is added to the pool, any publishers that are in need of replication, that in other words, they don't have enough indexers already to replicate as per the configure replication settings, that new indexer will be assigned those publishers right away. Otherwise, it can just sit there and wait for new publishers. And when an indexer is removed from the pool, the coordination service will reassign that indexers, the one being indexer being removed publishers, it'll reassign those to other indexers that are available to accept that assignment. The coordination service can do some other useful things. One of those is it'll be able to poll the indexers. And when the indexers are at 20%, it can when they're at 80% capacity, in other words, they only have 20% of their storage remaining, it will be able to inspect the other indexers to make sure that there are other indexers available to take on that the assignment of the publishers when the almost full indexer finally gets full. And if there aren't, then it can alert administrators until something can be done about it. So it gives it enough time to send out alerts and have a person be able to react to the need for more resources in the pool if it predicts that there's not going to be enough indexers to take on the additional load at some point. So what happens when an indexer does get full? This is where we have what's called freeze mode or frozen mode and publisher handoff. So when an indexer reaches 90% capacity, it'll automatically go into a frozen mode. It's a special mode where the indexer stops ingesting any new data, and it only responds to removal adds and metadata updates from its assigned publishers. The indexer continues to respond to any queries for index data while it's frozen. It just can't accept any more new data. So it's not going to grow in size anymore after it's frozen. When the coordination service sees that the indexer has become frozen, it will then assign that indexer's publishers to other non-frozen indexers in the pool, and the new indexers will sync with the last CID that was handled by the previously by the frozen indexers. So it'll pick up where the new indexers that get assigned the publishers will pick up where the frozen indexer left off. So one of the results of this is that the indexing data gets spread across multiple indexers, even if it's from the same publisher. So, for example, if we had an ad chain on a publisher that from A to Z, and so first indexer gets A, B, C, D, then freezes because it's full. Next one gets EFG, then gets frozen. Next one gets HIJ, and so on. You can see how it'll be spread all over the indexer pool. And that's fine. It allows us to just keep adding indexers as more and more data pours in. So as deletions occur, there may be sufficient space to consolidate some of the frozen indexers or possibly reinitialize them into the pool if their data is no longer useful. So there are things that can be done with them. But the point is that the freezing provides a way of handing off the data. So basically, freezing is a graceful way of letting the data that's coming into the indexers overflow from the full ones onto ones that aren't full, and it doesn't involve moving any data around. So if you think of other strategies that adding indexers or adding a node to a network would cause a redistribution of data, even a minor one, that could be very expensive in an indexing situation just because of the amount of data. That could be expensive and very time consuming. So having this freezing strategy allows us to handle full indexers without moving any data around. What this requires is scatter gather queries, because any indexer or all the indexers could have the data that's being looked for. So a client doesn't know which indexer to ask, and there's no idea of which indexer might have an answer for any key. Multiple ones might. Multiple providers could provide the data for a key. So we have to have the ability to do scatter gather queries. We already have a service that does that. It's called Index Star. And since we have a homogeneous network of indexers right now, we already have to do that. So this service is already available and working well. And it sends a client query to all the indexers and collects their responses and merges them into a single response back to the client. So It also does things like is able to have circuit breaker logic that if an indexer becomes not responsive, it's not going to wait for the response from that until it becomes responsive again. And the index star is currently, like I said, is currently working, and we're able to, it's a necessary part of this network. So scatter gather queries, yes, they do multiply all of the incoming queries out to the, by the number of indexers in the pool. So this may be some cause for concern because it's if the query load is sufficiently heavy, but right now it's not. We cache, the cache takes care of about 95% of the query load. And what does get through is actually fairly small. Queries themselves are small, and so are the responses. So it's not taking a huge amount of processing power, network bandwidth, or anything to deal with the query load at this point. That may change at some point in the future. But currently, we're not really, we don't feel that we need to address that in this step. But as that does increase, what are the next steps? One of the eventual strategies that we'll get to is, and this depends on a number of factors which we don't know yet. This is why it would be considered a next step. Is we would want to distribute the query load by sharding over the key space. In other words, different indexers would be responsible for handling a different portion of the key space, and we do something like that with a consistent hash. We'd split the ingestion layer and the query layer into two separate layers, so that the ingestion could be handled separately. The servers or the nodes handling ingestion would then write their results back to the query layer that's key sharded, and queries would then be directed based on their key to specific nodes in the query layer. That may prove to be critical in the future. Could also be problematic just because of if there's any need to redistribute data. Even though consistent hash minimizes it, the sheer amount of data could be a problem. So it's a matter of weighing cost versus benefit, and we don't really have all of those factors yet at the scale that we'd start being concerned about it. So that concludes my presentation. Thank you very much. Here are some links where you can find more information about the indexers or get in contact with us. Feel free to reach out. Thank you very much.